Hi, and welcome to this video that is going to demonstrate how to solve quadratic equations with imaginary roots using the quadratic formula. You should have some familiarity with what the quadratic formula is. It's right here, okay? And it, in fact, works on equations of the form ax squared plus bx plus c equals 0, okay? You should have some familiarity with what we mean by roots, okay? So roots are equivalent to zeros, or synonymous, I should say. It's also equivalent with x-intercepts. If they are, in fact, real zeros, they will, in fact, hit the axis of x. And then, as an explanation that's a little more detailed, they are the inputs that make an output of 0. Good math notation for this sometimes is seen as x such that f at x is 0. Again, the input such that the output is 0. Okay? So just a couple of quick examples on how to use a quadratic formula here where you'll encounter imaginary numbers in the answer, and let's show exactly how that works. So if you notice here in example 1 where it says find the roots, I'm going to in fact, show you the graph of this on the calculator. Okay, if you notice it's x squared minus 6x plus 12. So I will just graph that equation. And if you notice, we see a parabola, which is not a shock, and it has no x-intercept. So we'll anticipate imaginary roots. Okay, so let's just get the work on that, and we will quickly make an ABC chart, which is always a big help here. We've got A equals 1, B equals -6, C equals 12. Always good to organize your information. It helps raise your level of precision. So then we are going to go with X equals the opposite of B. Again, I'm just plugging in here. I'm not doing any work. Plus or minus the square root of B, which is -6 squared, minus 4 times A times C, all divided by 2 times A, which in this case is 1. Now, before I go any further, I want to make sure I just hit something that's very important here. Right here in the B squared part under the radicand, the first term of the discriminant, it's called, it's really important that when you set this formula up, you get into the habit of using parentheses there. If you don't use parentheses and then type on your calculator without them, you're in fact going to get it wrong and not even know it, especially if you are not typing just that term, the whole discriminant. Okay? So, let's continue on. And we'll just start by the way of the order of operations, start to simplify. And I'll get x equals the opposite of 6, negative, which is 6, plus or minus the square root of 36, minus this guy here is going to be 48, all over 2. Okay, scroll down a little bit. Continuing underneath the square root sign, we get 6 plus or minus the square root of -12, which dictates that we will get imaginary roots here, all over 2. Great time to go to the margin with our square root of -12, which is -1 times 4 times 3. Again, looking for the biggest perfect square that is a factor of 12, as well as making sure we break off the negative. This will, in fact, give us 2i root 3, because the square root of 4 is 2. The square root of -1 is I. Okay, so putting that back in the problem, I'm going to get x equals 6 plus or minus 2i root 3. I'll just keep the color coding so you can see it. All divided by 2. Now I will divide both terms up top by 2 in the numerator. So I will get x equals 3 plus or minus 2 over 2 is 1, I root 3. This can be checked on your calculator with significant ease as long as you remember to put your calculator in imaginary mode. So if you see here, if you hit the mode button and scroll down to where it says real, go over to a plus bi, which I already have highlighted. Make sure it's on. Quit to go to your home screen and do 3 plus second decimal point is the I, second square root of 3. I have the right arrow in this operating system to get out of the radicand. Store x, hitting enter there, converts it to a decimal, but it's still imaginary form. Just need to scroll up to look at the equation, and you'll see I'm looking to get x squared minus 6x plus 12, and if it is a root or is 0, it is the input that makes the output 0, and it does. I could scroll up to where I stored the x value and change the plus to minus, so that both answers can be checked. You can do that at your leisure. I will do that just at some other time. I'm going to save a little time and move on. Okay, so now, if I can just take a second and maybe shrink this so I can make a little bit of room. Okay, so take a look there and make some room. Wonderful. Okay, now in this example, again, I want to show you the graph first to reiterate the fact that when we're dealing with quadratics, where we get imaginary answers, the graphs are very specific. So I'm going to highlight the equal sign there, unhighlight the equal sign there. And you see, I believe, in fact, I have the equation, right? Negative 2x squared minus x minus 5. Excuse me. It's actually minus 5, so I'll change that here. Hit graph, and you'll see a bit of a parabola that is inverted because the lead coefficient is negative. And you see that it also does not have any real zeros because there are no x-intercepts, but it could have imaginary zeros. So we will go to look to find them. And we will do that by the quadratic formula. Again, I will make an ABC chart, which is going to give me A is negative 2, B is negative 1, C is negative 5. And then continuing on, we're going to get x equals the opposite of B, which is negative 1, plus or minus the square root of b squared, again in parentheses, negative 1 squared minus 4 times negative 1, which is negative 2, times c, which is negative 5. Again, I hope I said that correctly. B squared minus 4ac, all divided by 2a, which is 2 times negative 2, right? And then by way of PEMDAS, we'll simplify. X equals the opposite of negative 1, which is 1, plus or minus the square root of 1. And then this part here, if you notice I have negative times negative times negative, that will be a minus, and then 8 times 5 is 40, all divided by negative 4, which is giving me x equals 1 plus or minus the square root of negative 39, all over negative 4, which if you notice here, if I go in the margin to look at the square root of negative 39, I can only split that into negative 1 and 39 because its factors are 3 and 13, neither of which are squares. So that will, in fact, simplify to I root 39. So I'll continue to plug that back into my calculation. X is equal to 1 plus or minus I root 39 over negative 4. Now when I divide both by negative 4 here, there's a bit of a trick that you need to be aware of, okay? We're going to get that x equals negative 1/4 plus or minus I over negative 4, but we're going to get I fourths, and we can ignore the negative sign now, actually, because of this plus or minus. Okay, I'll explain that in a second. And that's going to be root 39. Okay? And I will circle that, and that will be our two imaginary roots for this function y equals negative 2x squared minus x minus 5. You can check it on your calculator, but I want to spend time talking about this notion of this plus or minus and this negative not being here. Okay? Just a quick little sidebar. If you notice, if you have 2 plus or minus negative 3 and 2 plus or minus 3, well, this is kind of going to split into 4 problems. Both of these problems will split twice. So the first one here is we've got that this 2 plus 3 is 5, and 2 minus 3 is negative 1. So 2 plus 3 gives me these two answers. Excuse me, 2 plus or minus 3 gives me those two answers. So here, if you notice now, I've got 2 plus negative 3 as well as 2 minus negative 3. Well, 2 plus negative 3 is negative 1, and 2 minus negative 3 is 5. So you see, if I've got 2 plus or minus negative 3, I'm getting the same two answers as if I did 2 plus or minus negative 3. So what's the moral of the story? If you have plus or minus and negative, you can ignore the negative because it would be the same result. So that is the routine in a nutshell for the most part on how to use a quadratic formula to find imaginary roots. Feel free to watch again. Feel free to practice. Feel free to tell your friends.